Welcome back. I hope you enjoyed the lunch and you also had the possibility to have already some discussions with other participants. Now we want to start our partner reference presentation. And I'm very glad we are starting with an exciting retail logistics project in Spain, which was realized by our partner Mirta Logistics. And they are a long-term WinCC UA partner, and they brought their SCADA expertises and WinCC UA to a complete new industry branch, the logistics. So please welcome one of the main actors in this project with me on stage, Neos.
Thank you.
Here we go.
Perfect. First of all, I would like to thank Siemens to let us to be here, to be able to share with all of you the way we do SCADAs, high-end logistics SCADAs. In fact, there is no much difference between transport systems or logistics systems. In fact, what we are doing is monitoring different things. We are monitoring cars, we are monitoring boxes. The thing is to obtain all the data, to collect everything in order to obtain the tool the customer needs. It's going to be the daily tool, and it's a tool that's going to be used for 300 users. 300 users because they have, in this kind of sectors, they have a high rotation of people with no time to be trained. So the SCADA has to be very useful. It has to be high fidelity with the real plant. It needs to be exactly. So the hot points of this kind of projects are, first of all, the real images in order to show the operators where everything is located. The adaptability, because as every customer, as all you know, we have all the time new requirements, new features to implement, new things, and it's a continuous changing every day. And of course, in these huge warehouses, we have to be able to communicate with a lot of devices. We are talking about for more than 100 PLCs, thousands and thousands of variables. In this project, in those projects, we can go up to 1 million data points. I want to share with you a video because I think a picture paints 1,000 words. It will be easier to understand it. Whoop, sorry. Sure one, only 2 minutes, don't worry. Well, that is. Now when we talk about it, what can we focus? This kind of projects, it's very important to create a good architecture since the beginning. It means that when the project is starting, it's very small, but it needs to be scalable. It means that it's going to grow and grow and grow. We do a release every 2 weeks. It means that we have to be ready to grow the system with all the servers, and we have to be prepared to be ready. We have to choose a distributed system. In that way, we can afford to get all the variables in different areas of the plant. We are talking about to obtain between 500,000 and 1 million data points, and we are managing with all of that data in real time. As I told you, and as you have seen in the video, the graphics are really important. Why? Because, as I told, there are many people working there, and it's important to focus where the device is located. Sorry. And the functionalities, they always want, all the customers want to implement new functionalities anytime. New reports, new animated graphics, new alarms. They are continually asking for new features, and we have to implement all of that. I want to talk about 2 features that have been implemented, talking about that. The first one, there are the possibility to create alarms in runtime. What does it mean? It means that we have, for example, 2 machines. Separately, they are working properly, they have no problem at all, but the logics between them, it doesn't fit, it doesn't work. So it means that we have a problem in that. We have blocked the system. We can create an alarm specific for that. Meanwhile, the OEMs can fix it, and then we will erase that alarm. For the moment, we will have our alarm for tell us what is happening. In the second hand, what we have done also is to send to the operators the most significant alarms of the plant. It means that they have chosen different alarms to tell us, I'm going to be located in this area. I want to receive only the alarms, the most important alarms of this area. They can choose it from their own smartwatches, and they are receiving only the alarms they want. And if not, they are not listening the other ones. If they move to other area, they can change, they can switch, and they are receiving the new ones. That can help them to make good decisions at any time, because they only receive what they want at the time they want. I think interesting in this kind of projects is that we have to work with different people in our team. It means we have back-end developers, they are doing the core of the project, they are doing the WinCC OA system. But on the other hand, we have graphical designers that they have no idea about industrial system. We have also user experience, user interface developers in order to tell us how we should represent, how they are going to be in the front. And for sure, the industrial engineers. They are going to put us new sensors, to add new data points, to explain what the meaning of the data, and we have to mix everything. Of course, that's a completely mess because we have a big team. It's difficult to manage with it. And the best way to do it, what we have said, doing best practices, choosing the good architecture, and doing continuous integration, continuous testing, continuous deployment in order to have the success project. Here we have found the cloud as our best friend. We are working daily with the cloud because in this kind of systems, if you have to test, if you have to develop, you can go upload everything to the cloud, switch on all the servers you need, test everything, and then once it's finished, once you know everything is okay, you turn off all the systems and you continue on your own. The importance of this architecture, we have three environments: the development environment, the quality assurance environment, and the deployment environment, and the stage environment. What does it mean? The development environment is going to be used for all the It's going to be used for all the developers. They are going to push any changes, and we are going to fix, to test, and to build all the data. And we are going to be sure that the coverage is done as expected, in order to be sure that the code is well done and we have no problems at the end. The continuous testing means that we have to develop, in fact, automated testing for all the features we want to test, the functionalities, and once everything is in the cloud, we can test continuously. In order to be sure that once it will be in the customer server, it will work correctly without any problem. And finally, we are going to talk about continuous deployment. The continuous deployment means that once all these tests has been done, we for sure can install it in the server client, because we are sure that everything is going to work okay. It's very important doing these steps in this kind of projects, because we have there are continuous changing. Every 2 weeks we have a new release, as I told, and it's important to be sure to be quickly to do the changes well. And that's all. Thank you very much for your time, and if you have any questions.
Thank you, News.
You're welcome.
Thank you for this interesting presentation. Now I would like to welcome our next speaker, which is Mr. Sean Sandoval. He's the founder and the president of Chasm, our most successful partner in the US. And he will show us the role of SCADA in the IoT era. So please give a warm welcome to Jean, and Sean, the stage is yours.
Okay, microphone check. Thank you. Frank, you're doing a great job. And a round of applause for all of our presenters this far. Been pretty inspiring so far, so let's give our presenters a round of applause. So my name's Sean. I'm president, founder of Chasm, Seattle-based company. And before I get started, I got in a conversation last night with Peter Anik about soccer, football, right? Everybody's pretty big fans of football over here in Europe and across the globe. What I didn't realize is that all the soccer fans were equally as big of fans as OA. Because I was looking on YouTube, and there, what's the chant? OA, 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 OA. So Peter, let's make a new theme song for WinCC OA. So everybody together. OA, 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 OA. OA, OA. One more time. You don't like football. Come on. All right, great. Hey, give you guys yourselves a round of applause. Okay, so Chasm, we're a Seattle-based company. We do a lot of things there, but we primarily sell, support, and train for WinCC open architecture software. So we do pretty intensive system architecture design in conjunction with our engineering partners. So we're trying to get the product adopted in the United States. So we're trying to be very focused and getting more people aware of it, so that next time we have these events, half the room standing up is from the United States. So we're trying to be like you. MES consulting, we do a lot of that. Technical support. In conjunction, we work very closely with the Siemens HMI Center of Competence in Plano, Texas. So we're really trying to create a localized infrastructure that's level 1 and level 2, primarily so that we can provide the local regional support to increase frequency with our customers. Product education, always trying to educate. We adopt open source mindsets, so we're never trying to put our hands around things that we find out. We're trying to organize and push that information out to the market. Then we also have a partner software development company where we're trying to build apps, build tools that we can in turn send out to the market as well. Okay, a little bit culturally about Chasm, who we are, decision-making process, what's best for the customer, what's best for the company, and then last but not least, what's best for you. So we really try to be customer-centric in everything we do, and we're always asking a lot of business-related questions in terms of SCADA and just software in general so that we can focus on solutions and not products. If we get too drilled down into the product nth degrees, then we're going to miss something, and then we're either going to put them in a platform that's not going to scale or be able to move forward from that. And then be responsive is another tenet. Everybody wants things here and now, so everybody's on their phones. They can go get whatever they want at the drop of a hat. And so because these solutions can be so technical, we want to make sure that we're answering the phone and calling back at people in a timely manner. And then really trying to build one big brain, right? None of us are as smart as all of us. So that's who we are as a business. Three kind of key areas, right? Educate the market, create an ecosystem, and then put the wrapper around it, support you through the process, all for happy customers. So this is one of our brewing customer. We've built quite the little user base of brewing, not only because we like beer, but they seem to like the product. And we do lead with WinCC open architecture, but it's nothing more than our marketing strategy to sell the entire solution because it's a very data-centric platform, as you all know. Snapshot of some of the customers we do business with. We've got over 90 active customers, multiple vertical markets. So the ones highlighted there are critical infrastructure, water, wastewater, city and county of Honolulu. So next time you're in Hawaii having a Mai Tai, rest assured your water is coming from WinCC OA. We also do discrete manufacturing, so Boeing and Honda is here, one of our customers. Yep. And we also do process as well. So we have some oil and gas customers, some renewable energy. UET presented a few years ago in Bilbao. And then my personal favorite, because it's my background, is food and beverage. And not only because we like beer, but we have multiple brewing customers using the software. One common component challenge that they all have is the market's been migrating from essentially HMI, right? We took panels that were really old school, driven by contactors, and then we basically visualized onto an HMI screen. But over the years, software, SCADA, has been developed to what we just saw earlier, right? And so for years, the people in this room and the people who wear the badge of SCADA engineer, we've been doing these things for a number of years. So all these new fancy things are coming out, and we all probably shake our heads like, yeah, I've been doing that for 10 years already. So I want to start in, the topic of my presentation is to how is SCADA relevant with IoT? So you've heard it twice, like Mr. Stauffer, Frank, everybody's giving ideas. So I'm going to share some ideas of things that we're coming across. But let's start here. And I'm going to pause that because I forgot to move the... Can we get some audio down here? Oh, no. Well, so what's happening right here is this guy shows up. It's an IBM commercial. Guy shows up, and he's just like, hey, your refrigerator's broken. The lady's like, no, it's not. And he goes, yet. So that commercial came out circa 1999. And so IBM was promoting IoT before we even had the name IoT, right? And so why? We always ask, like, why is all this stuff coming to market? Why are we getting all this stuff? So I'm sharing market conditions here, too, so that you can maybe take some of these things and manage your businesses, more effectively. But a gentleman by the name of Gordon Moore in the 1960s wrote a white paper on the idea that transistors on a circuit board or on a chip would double every 2 years, right? And it later became known as Moore's Law, to where we're from the 70s up until now, we were at 10 billion transistors on a chip, all right? Up until about a year and a half ago, they hit 20 billion transistors on a 7-nanometer chip. Give some perspective here. That's a human hair. 20 billion transistors. A human hair is 50 to 70 micron. 1 micron is 1,000, takes 1,000 microns to equal 1 nanometer. So it's significant, right? Basically, put it in super layman's terms, if we printed out a piece of paper with 18 font, in 2 years we could print out that same piece of paper in 9 font, 4.5 font, 2.2 font, and so on and so forth. So that's what's happening. We're being able to do more with less to the point that we all have supercomputers in our pocket now, right? And so that's driving a lot of what's happening in the market and the whole Internet of Things explosion, right? Our phones, and people are growing up with it to where really, that video circa 1999, we had 500 million devices connected to the Internet. Most of them computers. But fast forward, we're looking at having 50 billion devices connected by 2020. Significant, right? So it's pushed the market to sensor to cloud. And this is what we're dealing with now. So commercial market's gotten a hold of it, and we'll call it, IT, or even, your kids probably 7 to 10 years old are doing stuff with sensors on their phones, right? And it's just kind of like, it's commercial IT, it's not industrial grade. And so we got to look at things in terms of like what's happening out there and where do we fit, how do we play together, because at the end of the day, the challenge that we have is dealing with industrial data. So is this what's happening out there? Yeah, commercially, this is what we're hearing. Even internally, we hear spats with different groups and everything, and cloud software. Is this the right approach? I don't believe so. We work with a lot of corporate IT people, and they always say, Sean, it's real easy to go to the cloud, not so easy to come back. So I promote a love affair. So why? Let's ask why again, right? So if we start looking at the different types of data transactions that are happening, this is the ISA 95 that I hacked up a little bit to kind of make sense of this whole thing. But really, what's beautiful about WinCC OA is it allows you to do more with less, right? You can cover different segments of the business. HMI, it's just something it does, right? It's core functionality. SCADA does that. Can be an edge device, does that. Does MES. I know some people would like to object to that, but I respond to what our customers and how they're using it, right? So it really covers this whole segment of the business. And then how it's important is like on the left-hand side of this graphic is really what do SCADA systems and field devices do really well. They handle millisecond and microsecond data very well. And they handle all the way up seconds, minutes, hours. That's really kind of our core bread and butter. But then once you get into like that MES layer and it gets gray and into the enterprise level, that's where we're seeing the advent of cloud, process analytics, so on and so forth, because it's more transactional data, more unstructured, more all of that. So that the fact that we're looking at NoSQL databases is awesome because it gives us the opportunity to be a really good fit in that middleware component. So take a look at this from a financial aspect. So here's the same automation pyramid, but on the right-hand side, let's think about depreciation cycles from a business standpoint. So when people install their infrastructure like pipes and everything, right? When they put a pipe in the ground, they're anticipating getting 50 to 100 years out of that before they ever open up the pocketbooks again, okay? Next step up, how many of you have heard modernization, PLCs? This is the first time in our generation we're going to see this much change happening with the PLC. Please raise your hand if you've heard that. Yeah, okay. So we hear that all the time, and it's because when somebody buys a PLC, they're typically looking to hold on to it for 15 to 20 years. But once you get into the software stack in the IT world, the change is happening more frequently, 3 to 7 years. Gives opportunity to modernize. So if we look at a very simplified version of this technology stack and bringing it back to WinCC OA, the devices are coming out enabled with RJ45 ports or even like their own embedded web servers on them now. There's all kinds of stuff coming on. And so what's really cool about WinCC OA is you guys saw the MQTT piece on there, right? So MQTT is pretty awesome. There was a picture of Node-RED up there. Awesome tools, right? But not only can we traditionally connect to PLCs, but now the roadmap has the MQTT components coming out, where we can now do directly, not just through the stack, but we can be sensor to device, right? Or excuse me, sensor to software. So pretty exciting stuff seeing this, and I actually had to unhide that slide after I saw the unveiling of that. I kind of want to leave that uncovered. It's very nice. Okay, so I'm not going to call it digitalization. I'm going to call it a digital transformation because it's a journey. Most people don't go from a level 1 to a level 4 overnight, right? So we got to really understand the different components of it and really what the business drivers are for what people are trying to accomplish. So if we look at kind of 3 components at the base level, integration of the automation layer. Like, let's get our data organized, right? And most people want to start with just visualizing it. Next step, we're trying to add situational awareness and efficiency response. Still handled a lot by SCADA systems, and that's what's directing traffic. So process analysis, right, can start as simple as a trend tool and then move from there. And then last but not least is data science. This is where we're starting to see cloud-based type solutions, those types of analytics, to where we get to predictive control, to where we're getting to data foresight to be able to have a crystal ball, right? Machine learning, all those types of components. Ultimately, to optimize the business, because people are making stuff, right? They're either making stuff or monitoring processes. So everybody wants marginal contribution. We're trying to reduce the price it is to manage a process or to produce something, right? So if we can get to that optimized level and successfully move our customers through this journey, we're going to be very successful. Data how you like it. One of the things we like about WinCC OA, on any device, anywhere, anytime, in context, right? So the maintenance guy addressing something, and the operator on the plant floor is going to look at an HMI panel. The business analyst is probably going to look at the EWA chart widget. By the way, guys, thank you so much for bringing that out. That is big time. Elizabeth mentioned this earlier. It is extremely important for what we're trying to do in the United States in the market for having a small IT footprint. Installer is still about 1 gig, but having the same platform that we can scale in lots of different sizes and use as an edge device, or use as a SCADA system, or use as XX and X, allows us to connect all these systems and quickly move people through that digital journey, right? That data transformation. Event-driven, not just on the device level, but transactions with like Oracle. So right now, we're working with a pretty well-known brand that they have a problem with transactional data from their business system to their execution system. And they need 8 databases in the middle to make that transaction because they're using standard time-based polling software. So we were able to reduce that IT footprint and connect with very minimal resources. Big eyes, like, wow, where's this product been? So event-driven, just all around, is a very, very key component. And then not only from a device level, but just the data model component. Being able to build everything into a template, multiple different configurations, and standardize it. One of the things we have in digital transformation, the problem we have is once you get up to those higher levels, you could break the whole chain of data flow if you don't have something that's flexible, hence the object-oriented environment. Now to the user references. Linde Specialty Gases, and this is probably going on YouTube, I'm assuming, right? So I can't really call out our competitors of who we beat. Okay, I'm getting egged on here. So Honeywell Process Solutions, both of them, replaced a Wonderware system platform, and Schneider Electric SIMATIC to win Linde Specialty Gases for 3 plants. And so what it is they have RFID sensors at every entryway into the facility. They produce gas that gives chemical baths to semiconductor chips, okay? It's 2-step gas. They have a leak. You have 2 steps to get away or you die. Morbid, I know, but OA is saving lives every day. So this is a picture of their UI. They wanted grayscale, kind of high-performance HMI. That little red button is down there showing an error or an alarm, parts per million, click it again, trend information immediately, and then they can go to set point changes and then alarm summary on it. So pretty basic for those things. But the really cool part is this. So when an alarm happens, everybody who comes in the plant, even if you're a visitor, you get a badge. They check it in, you get checked into the OA system. When that alarm happens, red sirens go off, a PA system happens, and then this mustering screen pops up. Everybody goes to a mustering station, and as they show up, everybody's name comes off of that list. And whoever's left, that's who they call and start checking on. So they're looking at OA video now, so that when an alarm happens, they can get eyes into an area versus sending people into harm's way to assess the situation first. RIXA, so one of our integration partners, Process Solutions, created a automated industrial refrigeration in a cross-platform application. That's the acronym. I can't believe I remembered that. But what they've done is they've built a ripening room system for food and beverage. So there's about 17 plants, Pandal Brothers Mission Foods. But in North America, I'm not so much sure here, but 90% of the avocados are managed by Mission Foods, and it's all ripened and managed with WinCC OA. It's pretty cool. And then there's a product that one of our other engineering firms, Vertec Industrial, just built. It's called MES Lite. They're doing performance analytics with WinCC OA. So they're actually integrating with production ID numbers from the business system, getting case packs, nominal rates, all those things, and pulling in downtime monitoring, OEE availability. And then what's even cool is I forgot to mention on the previous two, but I was kind of trying to blend together small cloud-based integrations. So they have Slack integrated. Anybody familiar with Slack? Collaboration tool? Pretty sweet, right? So when they finish a production run, the data just hits Slack, and Slack, everybody is subscribed to a production channel. They get updates of like production runs done, this is what was case packed, all that stuff. It's all being facilitated by OA. So the beautiful thing about WinCC OA supports webhooks, right? HTTP GET, POST, does these things that's already ready to support any type of cloud-based integration. And then we're working with an aerospace customer. I'm not even going to attempt to alias that one. But we just got approval. We've got about 30 servers on site for one of the customers. And we just got approval by their enterprise architecture team. This was just simply a proof of concept, so I did it, so don't beat me up on my graphics or whatever. But they are doing video monitoring. So robots are moving. They've got a pulse line. They've got to be very conscious of people. So if they walk the line of a fuselage, by the time they get back to the other end, somebody could be in harm's way. So they're using OA video to look at everything, and then their next steps are to start connecting to gate sensors like curtains, so on and so forth, so that they can start optimizing their safety stuff with technology. Okay. Then my last slide, something we're working on, which awesome you guys are releasing this platform, but we've built an OEE app called LiveByte that we've got up in the cloud. So the performance analytic or the processing happens in the cloud. The reason we wanted to do that is because typically we lose our customers when we say VPN. They just don't want that. They just want to log into a website and get data, right? And so that's what this does. And so then the other problem we have is like an external wide area network system can have a certain type of data, but then you go to the SCADA system and sometimes they don't match, right? And then it creates challenges interdepartmentally. So you want to have consistent data or else there's no value in it. Nobody will see value in it. So it's got to be consistent. And so what we've done is built a JSON hook inside of OA. So now the data is processed in the cloud, but it just comes straight down and updates what we call as LiveByte cards inside of WinCC OA. And so now we have consistent data being processed from the same area. And then different networks and so on. And so these things are happening out there because the customer wants them. And we're building them. We're taking them to market. We're building our ecosystem. And WinCC OA really is the thing that pushes us. So I'll leave you with this question. How can WinCC OA help facilitate your data to drive value in your organization? And thank you. I really appreciate the time today.
Thank you, Jean, very much for this very interesting interpretation and for this very interesting references you showed us. The next presentation is about digitalization in rail automation. And therefore, I would like to welcome Ms. Alexandra Berle from our colleagues from Siemens Mobility, together with Bobby Gomez from our Swiss partner Cleverdist, and they will explain us how they created with WinCC UA a digital station manager.
Thank you very much. So I'm the product manager of this so-called digital station manager, and today I'm first going to briefly introduce you to the business I'm working in. Then I'll talk about the functionalities of our product, and after that I'll hand over to our developers who will give you a more technical view on our product. Okay, so let's start. Well, what are we working on? So our solutions we offer to our customers, they increase the efficiency, operation efficiency of a railway station. And well, what do I mean by that? If you look at these two pictures, you see a lot of people accumulating in front of an escalator, or many people inside a train. And our solutions try to overcome this problem and also give the operator some help to manage the situation. And one solution we offer to overcome this problem is a so-called capacity solution or capacity forecasting solution. So by that we can tell the expected number of people at a station or inside a train, and then help the operator to take certain actions. And the overall solution we sell to our customer is what we call the Digital Station Manager. And the Digital Station Manager is a software product with a control system which is based on WinCC UA. And well, if you go to a railway station and you think about, well, what actually has to be controlled? There are different systems or different modules. And these you see on the left-hand side of the slide. Starting with the SCADA system, which is, in our case, escalators and elevators at a station. And ideally, depending on, for example, when a train arrives at a platform, you'd like to have all escalators down at the platform level to more efficiently bring your passengers from one platform to another platform. Another system which is very important for operating a station are the displays at the stations. So the passengers, they need to be informed very accurately when the next train is expected and when the next one will also depart. And this can either be done by a passenger information system, which are essentially displays all over the station, or by using loudspeakers, which we call passenger announcement system. So, and another system inside the station the operator would like usually to have access to is the CCTV system, so the camera system. And especially, for example, if somewhere an emergency button is pressed, the operator would like to have immediately access to the next CCTV camera to see what's actually happening. And our system can control these different modules, and we can either offer this as a complete solution to our customers, or because of our flexible system architecture, we can also only offer part of the solution. And another important point to have actually these accurate informations which are displayed on the displays, we need to have an interface to the trains. And this is what's shown on the right-hand side of the slide. So we have an interface, and from that we get information of where the train is located and when it's expected to arrive in the station. And this is very important, otherwise we wouldn't have these automatically messages possibility, which is then shown and also presented via speakers to the passengers. Another point is we can also access onboard units, and by that we could show the operator directly pictures, for example, of the next expected train in the station. So this is the basic idea behind our product, and where are we standing with our product at the moment? Well, so we have started the development of this product, let's say 1.5, 2 years ago, and we used all the past experience to create a new clean product. And what I mean by clean new product, this will also be explained later by Bobby. So today we have our first release, which we call DSM 1.0, surprise. And this includes a DSM core, so to say, and a passenger information logic. So we receive automatic messages from the train where the train is located, and then create the messages which are then displayed in a station. And this project, or this release, is currently engineered by our engineers for 2 projects in Buenos Aires and in Sofia. And how this engineering is done will also be explained in a second. So this is our current status, and we've already started working on the new release, which is DSM 2.0, and this will include many more functionalities, such as passenger announcement system, SCADA functionalities, and also CCTV system. And besides these basic functionalities, we are also working on, for us, more innovative topics. What I forgot to mention is also we have a cloud-based system, which might be interesting for future customers as a solution if we want to sell this, this product as a software as a service. And we are also working on the integration of, for example, the capacity solution I explained to you earlier into our operation control system. And yes, with that, I'd like to hand over to you.
Thank you, Alexandra. Thank you. I'm going to try to hold the microphone at the right distance. If I don't at any moment, please raise your hand. Let me just tell you why we believe that the digital station manager is important from the WinCC OA perspective. No? What are we doing different? And for this, I'm just going to bring you into a scenario with which probably a lot of you are familiar, independently of the business that you're working on. It's not about mobility. You can be in car manufacturing, water distribution, and so on. And you will find this scenario probably familiar. So imagine the situation where we win a project, fantastic. We have a wonderful product, WinCC OA. We've seen it, the new feature is incredibly flexible, it's best scale on the market. We get our client requirements, we go for it, we have an engineering tool, Getty, so on, we prepare for it, bang, we have a first project, who's next, right? So this is a perfectly possible approach for projects, and we are ready for the next one, right? The next one comes, there is a new WinCC OA release, there are new features, of course, the client is sometimes aware of the new features, they want them included. Yeah, we have the guys, they already developed one project, now we can reduce them, they have knowledge, they can certainly bring libraries, they can bring some of the know-how from the previous project. It's a little bit different, but, well, we go for it, and we have a second project. And you can already see that there will be more projects coming, no? There will be the third one, there will be the fourth one. By then, the first project will want probably a new update, they want to make a new change, so we send somebody from the project number 3, which is a little bit different already from project number 1, so we start having a little bit of problem here. Don't forget, we have to keep the maintenance of all of the projects and so on. Well, this is the story today for everyone, right? So, yeah, let's step back a little bit and come back from the initial scenario and think about the different way to do it, which is going to bring me back to a lot of the previous presentation we have seen today, no? It is true, like we were discussing before, that every year we're talking about the same things, no? This year, previous years, IoT, is it M2M, is it the clouds, the robots, the machine, clouds, and so on. I am happy personally to see that this year we also start to talk about more fundamental things. We are talking about, we have here it during the previous talks, adaptability, flexibility. What is the real fundamental difference from the previous decade to the current one? What is the thing that we are seeing, at least in our clients, from America to Russia, water distribution, petrochemical, what is the common need? I think the real thing is the need of being able to cope with the speed at which the market is changing. The market rules change very fast. So we need to be able to build systems that they are able to cope with this speed of change, right? So why not to follow the same approach as ETM is following for the product development? And if we are going to build a product that we want to actually replicate many times, that we want to actually be able to change, to modify, to bring new features to the market in a very fast way, and let's build inside WinCC OA. Since WinCC OA is so flexible, so powerful, it offers us the possibility, the open architecture opens us the door also to create our own framework, to actually be able to create an engineering tool inside WinCC OA engineering. So we make a specific engineering tool for our business, in this case, for mobility business, digital station manager. So of course, with this different approach, we can face the situation in different way, right? We can have a team that is in charge of the development of the product, and we have engineering teams that they don't need to have anymore that much knowledge on the product itself, but they can actually focus on their business. So is it mobility? Then I focus on my project 1, project 2, project 3, and we always shipping the same, exactly same product to all of the projects worldwide. So this was our proposal, and this has been our first implementation for Siemens Mobility. And I'm just going to highlight a little bit of the features of the different stages of the process that we saw before. So for the development, well, I have to say that this is using as a reference our experience when we were at CERN. No? At CERN, we developed already in the year 2018, years ago, we developed the same concepts somehow, right? There was the Jacob framework, which is a framework for high energy physics, for which 16 years later, I think this presentation is a couple of years old, this one here, there were already 650 projects based on the exact same framework, which is maintained by a central team. This is the exact same needs that we see in industry today. It's a high rotation of engineers, it's a high different demanding requirements from the end clients and so on. I think this will be an accumulated number of 100 million IOs in total. Some of these projects, 10 million IOs. So we use this, and also we incorporated flexibility into the new approach. So we use a flexible and maintainable object-oriented approach. We've seen the same thing in previous presentation today. So this is a little bit of the detail of the architecture. So we have WinCC on the bottom, but we have developed an object-oriented layer on top of it, in which we can create different modules, like passenger information, passenger announcement. This could be considered as applications, because we have installation tools, for example, so we can install different modules in different projects and so on. We have engineering-specific tools. We have also testing tools. Yeah. So speaking about quality today, we were also talking about quality. I think Elizabeth was very nicely explaining all the life cycle and so on. So we are using Git for versioning. We use also GitLab, automatic testing, so our software is being tested every night. Code analysis, automatic builds, issue tracking, so we are making sure that we have complete traceability, full traceability of all of the requirements. So this can actually be used even in SEAL-related projects, no? Yeah, we generate distributions. This is also important, this detail. We generate automatically distributions which are encrypted. So we have distribution for developers, which they can extend the core, but also for engineers that they go encrypted. So this way, you can ensure that no one can modify these codes. So this is for security, this is for IP protection, this is also to protect from involuntary changes even. Here we can see that we are performing reports every day. Code analysis, again, the coding guidelines that we agree with Siemens. So we have automated the reporting on the quality of the code, reporting on the unit test, code coverage, and so on. Yeah. And this is a detail of the unit test framework, so it's included into Getty. It can be launched by the developers, and we can see exactly all of the code, what has been tested. It helps to create the test cases and actually to run them as well. Okay, and now we're going to jump. So I don't know if you noticed, but we're jumping from development to engineering. So on one side, we have split the really deep knowledge on WinCC OA that we are putting into the product development. In the other side, we have the DSM engineers, not necessarily so specialized in WinCC OA, but they know about their business. In this case, they know about Metro, right? Here you can see a detail of installation tool that is integrated with Getty. So we have an installation tool that once we have a new version, it will tell us you are outdated, you are using this version, you can be using the new one. So you just install your new version of the software that is shipped from headquarters, bank. You get the new version, built-in enhanced security. So we are applying all the white paper from ETM regarding security. It's just built in the application. So root passwords removed. You are not root anymore. You are a DSM engineer. You have a new password, and you can do the things that you're allowed to do. We can see a bigger detail of this installation tool, where we can see that we also can create some sort of, we can import previous work from other engineers, so there is portability built into the concept, so different engineers can work in parallel. We can create engineering wizards that we're going to see in a second. This is an engineering wizard that is built inside the Getty. So there is really no need of para-interaction for the DSM engineers. They can use just a panel with a set of steps that they need to follow from translating the application from n number of languages that they are using in this specific project. Also to create the devices, for example. They use some sort of tool that can, for example, be used in combination with Excel. And it has another advantage. It's like once you export the new file, you can perform consistency checks. So if you import the work from other engineer, you can verify and you can see that, yes, you're about to create a new device, but be careful because 2 of your already existing devices has some changes according to the new engineering files. So we are ensuring also data consistency when different engineers are working in parallel in the same project. As well, we are creating all the logical views of the system. So plant model is also implemented using the same functionality. So just files, actually, file-based engineering. Of course, depending on the different applications that they are installed for a different product, there is a set of steps that are specific to that application. For example, for passenger information systems, we need to configure display templates, which is basically how we want to present the information to the passengers in the station, no? Which different areas and which is the information that we want to show. So these are the different steps that the engineer has to be performing. Role privilege definition, we have unlimited available granularity for the developers to expose different privileges to the users and so on. Packaging is a very important part because we talked about portability before. So once an engineer has finished working in part of a solution, he can just pack his work, which means whatever he has developed, devices, views, panels that he was developing, Windows and so on, and he can pack them and provide them to an integrator which will put the work of many developers together. We've done some enhancement in the user interface, so we create some helpers that help to connect objects to the devices and so on. Yeah, and just finally to give you a very quick highlight on some of the user interface part. It was fully developed using the layout manager features. So the application is entirely using layout manager, all the pop-ups, all of the windows. This means that you can resize, expand, collapse, and play as much as you need. So you don't need to develop for different screen resolutions, but you can use the same application. And we're using also the object-oriented panel functionality. This is a very quick clip where actually we showcase, as you can see, the metro line is centered. This was, by the way, a quick demo project we created in the office with our own tool to our first test of the DSM we made. So you can see that the layout manager is there, so you can make it big, you can make it small, you can collapse, and everything goes into place, whatever your resolution is. Yeah, also for different pop-up panels and so on, yes. So we can see that they should be also resizable and so on. So. Yeah, perhaps a couple more of details. Object-oriented panels. So you can see we have created, for example, like a day picker using this new object-oriented functionality, which is actually very efficient. We also created an emulator of an LED display, which is actually, you can see that we are really actually illuminating each of the LEDs. We are downloading the same fonts that the LED hardware is downloading. We put them into DSM, and we are really generating the text exactly as is shown in the displays. So it works with multi-language and so on, with scrolling, and all of these features that the hardware itself has. Yeah. And okay, alignment as well, so on. So this is really a little bit about the features, small features we developed there. But yeah, I think I would like just to close up the presentation to really go back to stress the point on flexibility. I mean, what we have developed here for Digital Station Manager is really a core that can now be extended with different applications, keeping really consistency of a single product that they can use worldwide without having to address the projects all the time as a new project. And I don't know, Alexandra, if you want to close the...
Well, nothing more to say. Thank you very much, Bobby, and thank you very much for your attention.
Thank you very much, Alexandra. Thank you, Bobby. Was a very impressive use case. I'm all the time impressed to see what you as our partners are doing with our product and what great solution and what great products you're creating out of them. Now we made it to the coffee break. I will kindly ask you to be back at 3:40 and then we can welcome our next speaker. So enjoy the coffee. So welcome back from the coffee break. It's time that we continue with our partner reference presentation. And the next one we have chosen is really a special one because we personally believe that it perfectly fits to the idea of digitalization. Based on WinCC UA and a team around Vladimir Zarochak developed a complete modular approach of a cyber physical production system. And I'm very proud to present to you Vladimir, and Vladimir will show us what it's all about, and let's see by yourself what's behind this scientific name. Enjoy.
So welcome to the presentation of Cyber Physical Production Systems. I would like to talk about one research project, what we are doing at corporate technology at Siemens. My name is Vlada Zarchak. I'm heading a research group for scalable and resilient architecture. And well, the topic here perhaps needs some kind of explanation. What does it mean, cyber physical production system? So if you look on today's system, we have on the left side, we already seen that today's presentation, we have automation pyramid, where we have all kind of software that actually Siemens is delivering from PLCs and controls through the SCADA systems, MES systems. Siemens is not doing enterprise resource planning systems yet. You have typically in a plant a lot of engineering, a lot of programming, plant configuration, various CAD systems. And we have the machines, and they are pretty dumb today. So they don't know what they're actually doing because they are controlled by the PLCs, and all logic is in a PLC. So what could be a cyber physical production system, and this is something what we are exploring in this research project, is a possibility that machines talk to each other, they communicate. Also the product itself, which is described here, can communicate with the machines. They start working on what product actually needs in some kind of collaborative fashion. And this brings a lot of flexibility for the future cyber physical production systems and smart plants. So essentially what we are trying to do is move all functionality which is in this automation pyramid down to the machines. So if you're talking about IoT, so Internet of Things, this would be ultimate Internet of Things where the machines themselves communicate to each other even without cloud, although we are using also cloud, and achieve in order to achieve production needs. So what kind of benefits has such a system? So you can have a self-organizing production units. So that means essentially you have empty plant. You can put mobile robots like in this example, or also stationary equipment. And if you start them up, they immediately start talking to each other and exchanging information about themselves. Then we have a notion, which is also the notion of Industry 4.0, that actually the product needs to steer its own production. So we need to have a digital twin of such a product in order that it can communicate with the digital twins of all these machines in order to achieve the goals of the product. And this brings a lot of flexibility in the production plans. And third, we have a concept of what we call plug and produce. And with this concept, we can actually build the plants which have very less engineering. Let's call it zero engineering at the level of the plant or production line. There is, of course, complexity of the systems going down to the machine, and I will touch this in later slides. So first to the project. The project already started a year ago. It's a project where we try to prototype such a system, and we selected WinCC as a best technology in order to accomplish that. So currently in Siemens has a lot of production plants, and one of them is also here in Siemens on Siemensstraße. So where there are a lot of product builds. So there is a product line CTOP, power supplies, and currently it's built rather manually. So there is an automation, but there's a lot of people doing production steps. The goal of this project is not to get rid of all these people there, but to enhance this production, that the machines can collaborate with humans, and we have a much more flexible production. So this is currently what we are doing in this fiscal year, and next fiscal year we are trying to enhance this system with a notion of new technologies like blockchain and MindSphere and machine learning, where we are focused on optimization of the system with the use of these technologies. So what kind of benefits I could have from systems like that? So the ultimate goal is mass customization, so that we can really produce a product with lot size 1, really individualized production. And the big goal here is what I think we already achieved is reduction of engineering, commissioning, and manufacturing costs. And since in the future, so the production plants needs to react to demands of the customer, which are more volatile every year. So the automatic reaction of the plant to changes in orders is something what we try to do in this project. So if you look on the requirements, what we gave ourselves, so we said, okay, well, let's pick 2 of these products. So setup product line PSU300E and Logo. So this is a power supply to Logo PLCs. And let's build a system. So from the theoretical point of view, let's really go to the real system and make a lot of variation of this product. So we can have, let's say, for this logo product, different kind of housing lids, different kind of electronic parts, and so on. And really to show that we can build this system with a cyber-physical production technology. And one important goal was also that we demonstrate the scalability of that approach. So if you have a couple of machines, it looks like, well, this can work, but maybe if you have hundreds and hundreds of machines, will the system work? So everything is decentralized, everything is going down on the shop floor. More or less the EMEA systems and other systems are only involved to getting the request to produce something, and machines doing themselves. Okay, so this is our system architecture, where you can see on the right side, couple of key design decisions what we gave to ourselves. So very important thing is that we're doing really everything within decentralized approach. Service-oriented architecture is a typical thing. So if you want to have a reliability, for example, then machines should communicate in a loosely coupled manner. So with event-driven architectures, communication architectures. Very important topic is that product steers on production. And what you can see here is on various levels. So we have here one production line with 3 machines. We are integrating also AGV technology. Second production line with 2 machines in this small example. And you can see that their architecture looks quite similar. They all have a digital twin or process image in WinCC way, where it's an object-oriented way expressed what these machines are capable of. And they have so-called skills. So these skills are capabilities of machines, what they can actually do, and they must somehow match what actually the product wants from them. At the level of the production line, we can also have a control there. In this case, there is no control whatsoever. It's really a decentralized production. In this case, you can have some kind of typical SCADA functionally there. You want to see if it's production line larger, so all the equipment there and their status. But again, so you have a digital twin there, and you have a lot of skills or services at that level. So this is something what we call fractal architecture, where the similar design patterns are applied at the lowest level and even on the highest level. So you can imagine, for example, that a 3D printer is a machine, but at the same time you can say, well, it's something like a plant, because, okay, you can produce finished products. So that means also at the level of the plant we are applying these capabilities. So essentially, if you have a plant which can produce, let's say, this set of power supplies, this is also skill of that plant. So let's have a greater look on how actually this production can actually work from the theoretical point of view, and then I can show you a demo video of the running system. So I already mentioned this plug and produce concept. So what does it mean? So if the machine starts, let's have a very small example. I have a conveyor, robot, and a CNC machine. They start up. Either we have indoor GPS system, they know where they are, and then that means they actually, based on proximity, they recognize, okay, well, we are near to each other. For example, this robot is near to the conveyor, or we are using connectors or LAN cables. So in a project, we are using Harting connectors, and then based on, because they are plugged actually together on a physical layer, they know actually they are near to each other. And let's say I have here the CNC machine. When they start up, in their digital twin, they express what they can do. So as an example, this robot here can do assemble or transportation. The conveyor here only the transportation, and CNC machine typically doing milling, but of course you can, with a CNC machine, you can also do holes on certain size. So for example, this could be a drilling skill. So when they start up, they find out also the possibilities where they can collaborate in space. So this is something what we call cyber-physical port. So essentially the conveyor can only send the products this way. Robot has a larger work area, and during the startup, they decided, okay, well, perhaps this is the best place where the products or work pieces go from one machine to another one. So this is a plug operation when I start the machine. When they're already running and I already do have some products there or work pieces, then a very important topic is that these work pieces has their own bill of process. So that we have to actually put information about how the product needs to be produced from the MES system where it is today, or PLM system before that, down to the machine. And let's make this a very simple example here. So let's assume that I have the product here which wants to have a drilling, a hole of this diameter, this length, and at that concrete position. So, and this is something what this product will tell the cyber-physical production unit conveyor there. Of course, product has no CPU, but the information about the product can be stored on the machines themselves, so that, of course, we are relying on the CPUs, so we need a computer actually controlling this conveyor, and that computer within RAM, you have a digital representation of that product. That means also that conveyor can read it and say, okay, what do you want? Oh, I want to have a drilling. Conveyor cannot do anything with the drilling, but can ask somebody else if can help me with that. So, for example, here in this case, this robot also cannot drill, but because it was plugged before with a CNC machine, knows that, okay, well, actually there is somebody who can drill. So with this approach, product goes from one cyber-physical production unit to another one physically, and the same happening in a digital space. So the information about the product is jumping between this machine, and essentially we are ticking off this production plan which is here. So that's the idea, but what are the skills? So how can we define the skills? So what can you see here is some kind of definitions based on current norms, like DIN 8580, VDI, and so on. As an example here, so we have a production processes like a joining, so you can do joining, so putting two things together, various possibilities, so you can do by filling, by pressing, casting, and so on. You can do gluing, so by bonding, or you can do welding. So this is an ontology, what we are reusing in this project in order to define a domain-specific language to describe what the product wants. So for example, in this example would be, well, I would like to have a pressure welding, and what the machine actually can provide. So I can do pressure welding based on a lot of parameters, what of course for all these skills are necessary. So if you look a little bit deeper, and now I'm doing first a touch with the WinCC OA, let's have a look on these two machines. So we have a conveyor, we have a conveyor, we have a robot. So from the mechatronic down, so there is a sensors and actuators. So this is something what OEM or vendor of this machine is providing. Also, there is a machine behavior, lowest level functionality, which is provided by for example, a robot. Robot can definitely move to the joint interpolation between 2 points, can open and close the gripper and so on. Very basic operations which are coming from the vendors. So the conveyor here is a little bit dumber, so because we need to control it via PLC, but still there's a lot of low-level functionality what I can control with a PLC. So I'm not arguing that we change that layer, so because this layer up here is something which really needs to be done based on hard real-time systems. There are the safety topics and so on. But on top of that, we have a notion of the skills. So in order, for example, to transport, the robot will use one of these behaviors here, like pick and place, in order to provide a transportation skill. And if I describe the transportation skill that all the machines can understand, then I have a system where I can integrate various transportation systems like AGV, like conveyor or mobile robot. And at the top of that, we have our plug and produce algorithm. So what we did in this project, still I'm saying it's a research project, it's not based on production capabilities yet, so we see the next fiscal year. So we did that, we implemented the skills here based on WinCC OA. So you can have an example here of the skill which is a transportation skill. So this is a data point structure, let's say, where I have a lot of skills here, and there is a description of this skill based on these norms. So this is the WinCC OA level, and then of course, if the skill is called by our plug and produce algorithm, because this robot just plays something here on that conveyor, then plug and produce algorithm will call one of the skills depending on what product actually wants. Either direct production skill, but in this case, well, conveyor is not doing any production steps, so that means conveyor can only transport something to the nearest other guy who actually can provide such a skills. So, and we have here, we're using S7 driver in order to communicate with a PLC, and the function blocks, what we program in order to move this conveyor, will be then called, and we have a small actor-oriented workflow engine in order to orchestrate these low-level behaviors, which is coming from the vendors, to high-level skills, which are now the new interface between the machines that they can actually collaborate together. So how does it look like in our plant? So it's a very small part of the plant. We did this design from some kind of hexagonal design where each of these wedges here actually is one cyber-physical production unit. That means each of them has a controller, so it's either Raspberry Pi or PLC or PC. Could be an IoT 2040 device. They can be plugged and unplugged from this robot here, so this is a very flexible environment where I can go with a forklift, take one of the table out, put something there, and I can start immediately a new production. We have also AGV, which is not depicted here, coming also as a cyber-physical production unit. And all these machines actually are exposing their skills. So you have examples here. We also integrated Amazon Echo in order to have a voice interface between the machine and human. So this is very beneficial because, as you can see, there is no border or wall between the robot and the human. So we are talking about the cobots and the safety systems here. So let me show you quickly a very short spot. Video of this running system. So we have a KUKA robot there. They collaborate together and exchange the cyber-physical products. We have screwing or fastening of the screws. This is the assembly of the product what I showed earlier. And what the robots are doing, they are dynamically calculating all the parts, so nothing is pre-programmed. So that means if we change the topology of the plant, change a cyber-physical production unit, well, the system is still there and will work as before because every path is actually generated on the fly. So how it is working actually, so let's go a little bit dive deeper, so how we implemented it using a WinCC OA technology. As you can see here for this example, we have two systems. They both have a WinCC OA running, one on the rack PC, another one is in this case a Raspberry Pi. What is nice about WinCC OA, it's also really scaling down to these devices. We have this system also running on the tablets and so on. So we can really do a very flexible deployment. And we can put this logic, this skill logic, on top of even very small and dumb devices in this case, because, well, of course, the price of the CPU and motherboards and so on of IoT devices is going down. So it's very easy to do. So we have a standard WinCC OA system. We have drivers for either this low-level behavior functionality, like here we are using S7 1200. Of course, if this would be S7 1500, so WinCC OA can run directly on that machine. In this case, we have a KUKA Sunrise cabinet, which is actually an industrial PC, which is a closed one, so we cannot run there. So that's the reason for our system here. So, and this is how it looked like from the lowest possible level. So we have implementation of the skills, which calling the behaviors, and this is essentially it. So let's have one concrete example. bear with me, it's a lot of technical information there. If I have a robot here, and currently the robot has access to two products or two parts. One is the transformer, which has a bill of processes here. Another one is a PCBA, so printed circuit board, which is bill of processes here. So this is our domain-specific language. Based on this information, what these two parts want, so this one wants to be assembled as a part to a product which is called a pre-assembled PCBA. This one other way around, and also this one also describing, yes, I would like to have it exactly here. And this is an assembly operation of electronic parts, or THT assembly, so-called. So you have to actually also define the pressure, so in newtons, and a lot of other parameters which are then visible here. So essentially, the robot actually compare what the product wants with its own definition of the skills, which is here. And if the constraints actually fit, for example, this robot can actually lift up only 7 kilograms of products. So, and it's fulfilled, so it's not a problem with these two products, they are very, very light, then this skill can be actually executed. If not, we have actually so-called producibility check before I actually start the production, where we're actually checking all the constraints if they are possible. So how we are controlling these robots? So we implemented in WinCC a new API manager, which we call ROS Connector. And this actually allows us to interface any WinCC OS system with a robot operating system robots. What does it mean? So there is an open source operating system, actually a framework or platform, which supports hundreds and hundreds of robots nowadays. Even the biggest vendors actually are providing either directly their software stack for that, or there are a lot of hobbyists to do so. And we have different drivers there, and then of course we can control a robot like this one. This is Universal Robot 3 or AGVs. So this is also something what we, during this research project, we developed in order to show that WinCC OA can control quite easily any kind of robots. So we already mentioned today that there is a lot of cloud technology available. So in this project, we also integrated some of them. So some of the parts will be in the future WinCC OA, like MQTT. So we integrated it a couple of years ago. Also, we have a connectivity to MindSphere. So we are putting all the data to MindSphere. Why we are doing it if I have a decentralized cyber-physical production system? Because I have to run a local decentralized optimization, which is not very effective, but I can run it in real time, more or less, and I have to combine it with a global optimization of entire plant. But I cannot do a global optimization every minute or every hour. So that means we have to actually combine the data what I'm collecting from entire plant and the data what actually every machine is doing. So, and also what we integrated is a couple of technologies. Text-to-speech is maybe the new interface for HMI. So where we can do text-to-speech and speech-to-text, again, so calling web services in the cloud. So what are the conclusions and lessons learned from this project? So even after 2 years, we already shown that there is a reduction of engineering and commissioning and even maintenance costs. Why maintenance costs? Because I can replace a machine with a dissimilar machine. So only one thing what this new machine actually can support, have to support, is the same skills and constraints. So I can replace a conveyor with a robot with a conveyor, if they match on their skills. Important topic is this mass customization. So I can really have a plant which is here and waiting for the orders, and if the product described in this bill of material and bill of process is actually matching the skills in this plant, then this plant can automatically say that, well, we can produce it. And this all works for the process automation too. We do not have a demonstrator, a real demonstrator with process automation, but we have a simulated environment where instead of the products, we have a liquid flowing through the pipes, through the tanks and other process automation equipment. And the concept plug and produce actually works exactly the same. And we also find out that this is especially suitable for contract or on-demand manufacturing. So our feeling about WinCC OA platform in this research project is very suitable for CPPS, can downscale nicely to production unit, can upscale to large CPPS systems. We tested it in Amazon Cloud with hundreds and hundreds of virtual machines, simulating each of them production units. And it's the first fully decentralized autonomous system because there is this publish-subscribe communication, so which is a very robust one. There are still challenges. So one big challenge here ahead of us is standardization of the skill ontology. So of course, well, there are a lot of standards in the world, and for each verticals you can find a detailed standards. So that means in order that equipment from multiple vendors can collaborate together, they need to at least agree onto this domain-specific language. But of course, what we can do is translate from one standard to another one, from let's say, from other competitors' standards to Siemens standard, and if you're integrating the plant, so we can use our standard. And then one challenge is, of course, shift of complexity from plant line level down to the machines. So machines are smarter. They do much more, and it's harder to implement them, to design them. But for the plant operator, it's very easy because they just plug and these things actually start working. And one challenge what we try to assess and change and research next fiscal year is really this optimization topic. Because if you have really everything decentralized, you want also that the machines themselves learn. And we are using smart SCADA functionality here. So with our language in order to have our clustering and other algorithms that machines learn. But it's a more suboptimal optimization because, yeah, I can see only the local thing. So maybe I end up with some kind of local optimum. That's the reason why we need to combine it with the cloud and machine learning in the cloud. So that was in a nutshell the project. Thank you very much for your time and attention.
Thank you, Vladimir, for this presentation about self-organizing production lines. Probably a producer's dream gets reality thanks to your solution. Now we would like to continue with our next presentation, and this presentation might be known to some of you already. Nevertheless, we chose it again because the topic and the presenter is a real highlight for you. He will show us his engineering tools based on WinCC UA through an example of a project for a central control system for subway installation. Ladies and gentlemen, please welcome with me the one and only Frank Mulder.
Thank you. So, good day. I don't like PowerPoint, so I only have a couple of slides for you. And I brought you something called TopAce. And, well, I hope you like it. It's a fantastic application that I made. You got it. We got some questions. Excellent. Excellent, Bernard. 3 fantastic and really spontaneous questions. So let me answer them. First of all, last year I showed you many tools and I got the questions from people, can we have them? And I had to say, well, sorry, I can't give them because it was really our core technology. And this year I made a change because actually this morning I uploaded all to the forum. So everything you see today will be in the portal, ready for your download. I also had questions, where's your colleague Joost, who was there last year? Well, Joost did answer the portal, but some guys have to work, we have to make some money. So Joost is in Holland, and well, if you like my software, feel free to use it and play with it. Well, next question, what is it? Well, actually, you just saw a very silly sample panel, nothing special, with a menu bar, title bar, really simple application. Now, in Holland, there's a document called TOPAZ, or TopAce in English, and this is a government document that tells you about the quality of software, and it gives you like 15 guidelines on how to make good software, and it talks about hiring good people, making a good process, but also some software guidelines. And I decided to make a tool to inspire you and to get you started with stuff like that. And one of the things, of course, is when you say, what the hell is this? Well, I made an application, and let me just open, for example, a title bar, and let me just add some icons, for example, the famous Bernard button. So, now remember, there are 3 buttons. Now, the first thing that I found in my company is that when we do testing, and someone says, well, I modified the title bar, the tester won't know what to do. He says, yeah, should I test the title bar or the menu bar or everything or the whole GUI? In the end, we test everything. So I told him, well, maybe I can make you a tool and I'll call it TopAce. And what it will do is it will analyze the project and it will turn the project into a graph using open source software. The graph that you'll see, you can see the same thing in Doxygen. And when I show it, you will see that the title bar is actually using the Bernard button 3 times here. Now this graph, which we just generated, tells quite a lot. First of all, you'll see that the Bernard icon is used 3 times, which is an indication about how often is your panel or script or whatever being used. The second part, you see dotted lines and you see solid lines. The whole idea is that the title bar is a panel opening a panel. When the Bernard panel has a bug, then the title bar can't crash. The title bar won't change functionality. So the idea is that when you change a panel like this, you don't need to test the title bar. On the other hand, here you see a script calling a script. When this script contains a bug, then it's quite likely that the calling script will also fail, will also crash. So the dotted line actually tells you about the risk that the submodule imposes. Then you see some colors. Well, the Topaz document gives a number of software metrics, and they're actually quite simple. They talk about the length of your source file, and they talk about the complexity of your source file, but with a very simple algorithm. And I decided to take their rules and to turn them into a quite comfortable menu item so that my colleagues can do this test, which is required by law, quite simple. Now, when I go back to this diagram, of course, where's my diagram? When I go to diagram, you'll notice that the CCTV and the alarm banner are red, which sounds not so good. Now, there are a couple of features that are built in, and one of them is that you can click on one of the items and it will show a sub-diagram. So when we take the camera, you'll see that the icon camera uses the script camera and the floor plan uses 6 of the cameras. Now, going back to the red one, you'll see that the CCTV is red. Now, the Topaz document, for example, talks about the comment in your code, and it talks about the famous McCabe index. And the McCabe index, according to Topaz, is simply how many if-thens or how many for next loops did you use in your code. Now, although Rijkswaterstaat in Holland, so the government, is only talking about the McCabe index, I said, well, actually, the number of if-thens for me is not the biggest problem. What I don't like is the ratio from between the number of lines and the complexity. For example, if you have a very small file with extreme big amount of if-thens, that's weird, that's complex, it's hard to read. Now here you see that this CCTV thing, well, the McCabe index is bad, and also you see the white lines. When we thought about this in my company, I sat with our developers and we said, well, what are the things that you don't like in source code? And they said, I don't like it when the source is like this. No white lines, no white space. And we simply decided on a figure that says, okay, how much white space do we like? How much white space would we prefer in our source code? Now you see this one is not so good. And if you now look at the library, well, you see this is really hardcore programming. And you see, this is uber complex. Yeah? This is something I can't even know what it does. And we decided that the number of if-thens, switch, case, whatever, divided by the length of the file should not be like this. This is absolutely terrible. On the other hand, you also saw that the alarms was also red for a different reason, because the white lines in this file is not good. And now when we look at this panel and we look at the source code, you will see what I mean. Oh, you won't see. But you'll see, well, a lot of code and not a lot of white space in between. Now there are a couple of very simple calculations but they do the trick for us. And I wanted to show you this because this is just for inspiration. I hope that you realize that there's a lot to be gained in quality. And some checks are quite simple. We saw just with Cleverdist, they had fantastic software metrics. This is really a first approach and a simple approach, but we do have the plans to extend to more complex stuff. But when I made this and I asked my colleagues, okay, the Topaz talks about number of source lines. And I said to my colleagues, how many lines do you have in your code? And no one knew. No one could tell me how much source code they had in the scripts, libraries, and in their panels. And just to give you an idea, there's a simple menu item that says Analyze Folder, and you just say Go, and it will show you how many lines. It will also show you how much of these lines is actually code, and how much is white. The rest must be comments. You see that some files are red because of the reason I just showed you, and some files, they don't have a calculation because they're simply too small. We decided that script files smaller than 20 lines or something are too small to do serious analysis. Now, another thing is, with our testers, is the fact that they don't know what changed, so they just test everything, which is a waste of time. Now, another application that I have here is that you scan your application and you then assign a name to this application, a version label. So we can call this user day, like this. Now, the nice thing happens, for example, when I now modify this CCTV library, which was already bad at the beginning, whatever. So, if I now scan again, and I now compare against this version that we just made, what I do is, it's simple to figure out the difference. But the idea is that when a good source file changes, the testing is easy. But when a bad source file changes, then the testing is also difficult. So in this graph, you'll see that when I change the Bernhard icon, which was a good icon, then this thing will be green. And for the tester it means, okay, a source file is modified, but it was a low-risk source file. It was low complexity, good comments. But when a lousy source file changes, like CSTV, then this is a warning for the tester, and it actually says the CSTV has changed and it is a bad file. But also, the control is in danger because a bad file changed and the control is calling this bad file. Now, in the end, the whole plan for now is, I'm working right now on a project for Rijkswaterstaat for bridges, and we have been asked or required to do this analysis. And their analysis is actually what I just showed you. So for the first time, I can now quite simply show them the results of our program efforts. And of course, this is the top-ace thing, but I can do this on their project. I can now finally present the right line numbers, I can present the right McCabe index, and I can show them that we measure, I can show them that we work on our quality. So my message for you is, if you want, play with my top-ace, but most of all, I hope you get inspired. I hope that you realize that measuring your software code quality is the next step towards improvement. There are beautiful tools on the market, but the scan can also be simple, so that's up to you. I hope that you think about this. I hope that you realize that there's a lot available. You saw in the early presentations, Cleverdist had some tools, earlier presentations had some nice tools. I hope you get inspired, and I hope that this way you can all improve the quality of your source code. I thank you very much.
Many thanks, Frank, for enlightening us and for showing us top-ace. So our last presentation for today will be done by a well-known speaker for the community. Like our CEO mentioned him already this morning, I'm very pleased to introduce my predecessor, Lukas Schopp. He's the founder and the CEO of this new startup called Sloop Tools, and he will show us in the next about 20 minutes some new ways for you to how to commercialize your solution or your add-on you build on WinCC UA. So welcome, Lucas. Please give once again a warm welcome also to Lucas. The stage is yours.
Thanks. Thank you to all of you, and it's so great to be back, either not to be ETM part, but to be back here on the stage. I love the user days, and I love all the community on the part, and that's all this is around the company I've now founded. I'm sure you know some of these, yeah? This is daily business in project working, yeah? Does WinCC UA does support this feature, what we need for the next project? No, they don't have it now. Maybe they make it in the next version or something like that. Or are we the first customer asking for this new feature which is not available, and why they don't have it in the product? Yeah, I've heard these questions a lot of time when I have been product manager. Yeah, and normally in the time when you are in the project business, then you say, okay, let it build this feature, this module, this functionality, what is missing for the next project, let's build it on our own. Maybe what's time, 1, 2, 3, 4 weeks, we don't know, let's try, we see, yeah? And then you have to maintain that, you have to enhance that and all that, yeah? And then after some time, then is the question, have we tested this feature, what we have done for the last project with the new version? Is this all comfortable with the new version 3.16? Does it work? We don't know, yeah? And then the best question, what we already had from some customers or from Cleverdist, the customer wants an update. So we need to show again and find out, is this all functional with the new version? And the community around WinCC UA is so great. So you are so great you have already enhanced WinCC UA with your custom features, with your custom functionality. We have seen that a lot of time today, yeah, that you built on top of WinCC UA a lot of functionality. And I was thinking about, is it not really easy and possible to make all these functionalities, all these extensions, yeah, available for all and each other to exchange that? And to show you this story, I brought my colleague Sarah with me, and she will tell you what is this story and what is Sloop Tools doing for that.
Planning and building the SCADA HMI part of a new facility line is difficult and time-consuming. Blue Limited has most of the parts already available, but what they are missing is an RFID module. So how much effort and time would it take to build this module? Could they buy it from somewhere? Building modules for industrial projects in a reusable way is great for later, but you can make some extra money by selling it. With the Sloop Tools store, you can buy and sell SCADA HMI add-ons. Sloop Tools has various services, such as an in-depth quality check of the code, an integration of a sophisticated license mechanism, know-how protection, handling of all the contract details, managing of all money transactions, and much more. The Sloop Tools store is transforming your SCADA HMI functionality into a high-quality, sellable add-on which is easy to find. Sloop Tools is much more than just an online store.
Thanks, Sarah. So that was the idea. We have built the Sloop Tools store. And I'm proud to announce it's online since yesterday. Totally surprised. And you can already register, you can buy add-ons. There are already someone on there, but I will tell you about this much later. What do we have in the Sloop Tools store? You can present your add-on, your functionality in a common way of a store, as you know. You can search through all the documents you deliver, so you can really find your solution for your problem for the next project. We have a quality gate. I will come to that later in more detail. We have a central billing, so we handle all the money. we have a contract management, so we have a template license agreement you can use to sell your add-on. So if you're not the big legal guy or company, you can directly take our template and say, okay, we take the standard template from Sloop Tools, and this is a license agreement, what is all fine for software delivering. We have various license types, so we build our own license mechanism on top of that. So you can license your software per one-time payment as it's normal on that part for a SCADA project. But you can also make some subscription models, so you can pay every year, for example, with included of upgrades and all that. We have an own ticketing system, so if you have a problem with an add-on, you don't need to find out who has provided that, because the add-ons which are online are from our partners, from you. So if you have something like that, an add-on, you can upload that to the store and can sell it. And if you have, anyone has a problem with your add-on and bug or something like that, he can go online to Sloop Tools and can write directly the ticket there, and we are handling all the way that the ticket is going to the right person. You can buy, or you can take currently and also in the future demo licenses for each add-on. Because we all know, yeah, there's a lot of documentation and there can be some nice pictures and screenshots and all that, but we need to have it in our hands and try it, how does this fit, and this all the functionality that's what I need for my new project. So you can directly download the add-on, have a trial version of 5 days for each add-on and can try that. And we have as well some additions you can directly sell with your add-ons. You can sell some maintenance contracts, support, consulting hours, directly in the time when someone is buying the add-on. He can say, okay, I'm sure need some support hours, so I buy the support package for 5 hours. It's all bundled to that. The quality gate, thanks to Frank, I'm totally with him. Quality of the code is one of the biggest topics in our business. Therefore, we built an own quality gate, an own quality mechanism online for the upload of any add-on. So if you have a cool functionality for your add-on, you transfer your code in a secure way to our server. We start one of our cloud server where it starts the quality gate. We check your files, if all the files are fine, if there is nothing bad inside. We make a static code analysis, something what Frank was showing with white lines, code lines, commented lines and all that. So we analyze your code and say what is inside of that. We check the complexity. We calculate this McCabe number, for example, what we all have learned, what it is. We calculate that, and all this information together from the complexity and static and file analysis, we compare all together, and then we calculate a quality score. And this quality score will be shown for each add-on. So you as a customer who want to buy an add-on, you can directly dig into and see how good is this add-on, which quality has this add-on. Because we all know when we buy something from someone, we want to know that this is in a good quality and I can use that. Then 2 steps more, we do all this license mechanism. So we add the license mechanism for you on that part, that the add-on is not able to be copied and used where someone has no license. So that's secure. And in the end, we all encrypt all files. So you can directly deliver the add-on and no one can really look into that it's because it's encrypted. And that's what we have currently, so today, all there. And the next steps here are the future steps we want to make. We want to integrate your unit tests. When you write unit tests, you can deliver them to us. And for each WinCC OA patch, for each WinCC OA version, we run the unit test for you and tell you if all is fine. So you get the report of your unit tests and your application tests as well. And the next point, security check We have already heard that in some of the presentations, security, security, security. We are currently in negotiations with some of the big companies about virus scans so that they can make an in-depth security check of your add-on if you don't do anything bad inside the add-on. So, and then you can have the stamp of the security as well. Yeah, as I have already told you, the store is online from yesterday, and to be honest, when I start to make a store and it's empty, it's not really interesting. So that's why I've come to some of my early adopter partners some months ago, showed them what I will do, what I will deliver, and told them, you can, as an early adopter partner, start right now to develop your add-on, and you can be one of the first people who are inside the community of Sloop Tools, and you can present your add-ons today. And to have maybe a short idea, who are these people, because most of them are today here, I would like to say that all the people from the companies maybe in a short time stand up to see that all of the people know who are they. If you have any questions, please stand up, all the early adopter partners. Yeah, thank you for that, because without your initial fulfillment of the add-ons from today, we could not make this happen. And I would like to try something, because I was a bit motivated from Sean for today. I would like to try something what Excellence is making every day in the morning. And they have some ritual, and does it say Sloop? Sloop? Thanks.
Thank you. You're done?
Nein. Ist die Zeit aus? Die Zeit aus? No. Just with a short look to the store. That's the store, and that's the initial fulfillment. We have today 20 add-ons in the store. So you can go online and buy some of these wonderful 21st add-ons. And maybe I show some of the information, what is inside, for example. You can click on one of the add-ons and you see it's something like your common in use, yeah? So that's like a store looks like. You can have as well some pictures and all that. Description here, you can have your try for 5 days, yeah? And that's the thing about the services. You can directly have the services here. You can click that all together and say, okay, I want the maintenance contract and I want warranty and all that. And it is automatically calculating all that, and you can now add it to the cart, confirm and purchase, and we will deliver as soon that the purchase order, and after you have paid, you will get the invoice and the license agreement, and you can go further, download the installer, which is a small application we built, and the installer will download the add-on, will install on your PC, will activate the license, and you can go on and use your add-on. As simple as it should be. And just, yeah, but Sloop Tools is much more than just an online store, I told you. We have a lot of services to think about, not just to exchange store, the add-ons. We have much more. The next thing is Sloop Tools Connect. And Sloop Tools Connect is something like, maybe you know My Hammer, yeah? So it's the idea to exchange each partner to each other for some project work. You need some database expert for the next project, so you can write into Sloop Tools Connect, I need a guy who is a perfect expert in database for next week who can help me. That's Sloop Tools Connect. And some next steps, one of the next steps would be PLC blocks. So we want to sell via Sloop Tools as well some PLC blocks, because you know the PLC block as well as the SCADA HMI part normally are perfectly fit to each other. So the best thing would be I can sell and I can buy as a customer both parts. I buy the PLC blocks over the store as well as the perfect matching faceplates and panels. That's the next thing. Currently we just sell in the European Union. Next step would be sell worldwide, and we have some more and more steps, but I think the time is more or less on the end. So you know that from me. Yeah. What is Sloop Tools? Sloop Tools, Alexander Tucker and me, and we have 2 friends of mine working on all that as well. So it's really something like the startup thing, what you know, but I don't have a garage, so we sit in my office, in my room. Maybe I have this question a lot of time, what is Sloop? Sloop does not something have with shop, Lucas, operations and all that, no. It's a kind of a sailing ship, and it was in the First and Second World War, it was a sloop, was the support vessel, so the support ship of the big ships. So we see Sloop Tools as a support mechanism, as a support of the SCADA HMI WinCC OA. So that's the idea.